Okay, hello, my dear children. Welcome back again to my physics class. So, you all know we are doing a chapter called machine. In machines, we have learned about levers and we are learning pulleys, right? So, in the last classes, we learned about the uses of pulleys, where we used pulley in the form of a single pulley in two ways. One was in fixed, the other one was movable. Means we were using a single fixed pulley and single movable pulley, and there we saw that single fixed pulley has mechanical advantage equals to 1, and movable pulley we saw mechanical advantage equals to 2. Yes, so when we say mechanical advantage equals to 1, means it is a pulley which is neither a force multiplier nor a speed multiplier. But even then we use a single fixed pulley just to change the direction of the effort in a convenient direction, isn't it? Yes, and we also learned about single movable pulley. Alright, so today we are going to learn about the combination, okay, of pulleys. So we are going to use several pulleys together. Understand, several pulleys together. So we are going to combine them. So in this combination, or the way in which we are going to combine them, okay, we are going to learn in two ways. One is using several pulleys where one of the pulley is fixed. So what we will learn? We will learn using, okay, one fixed pulley, okay, and other movable pulleys. Okay, and number two, what we'll learn several pulleys. We'll be using several pulleys but in form of two blocks. Understand? So we will be using several pulleys. We'll be using several, okay, pulleys in two blocks. Okay, and this system is also called as block and tackle system. Alright, so these are the two topics that we are going to learn. Alright, so let's learn the first one. In the first one, as the heading says, using one fixed pulley and other movable pulleys. So here in this combination, one of the pulleys is fixed and the rest are movable. Okay, so for this what we need is we need a rigid support. So here we have a rigid support. Understand? So here I have one pulley, okay, which is fixed, means this is a pulley which is fixed, okay, and I will have several other pulleys. Here I have the hook, okay, I have one more pulley here, okay, this is the axle. On the axle I have the hook, okay, and I have one more pulley here, okay, and here I have the axle and the hook. Okay, is that understood? So I have one hook here for this first pulley. Okay, let me name these pulleys. This is my pulley A, pulley B, pulley C, and pulley D. Okay, so here I have the hook for pulley A, here I have another hook for pulley B, and here I have another hook for pulley C. Understand? So here the three pulleys A, B, C are movable and D is the fixed one. Alright, now where are we going to suspend the load? Now load will be connected or attached to the pulley which is at the lowest level or at the lower side. So here pulley A is at the bottom at the lowest point. Yes, so here on this hook we will place the load. So let this be our load L. So load now, since because of its own weight will be pulled towards the earth, that is in the downward direction. So L will be acting in the downward direction. So to balance this I must pass a string. Yes, so I pass the string, okay, from pulley A through the first hook I have here. So you see that one end of the string is attached to the hook which is supported by a rigid support, okay, and the other end of the string passing through the pulley is attached to the hook of the second pulley, that is pulley B. Alright, so now this load L is balanced by this two segment of the string, okay, and is balanced by the tensional forces acting on these two segments of the string, and let those two tensional forces be T1 and T1. Now since both these segments are of the single string, so we'll have the same tensional forces on both the segment of the string. Now you know the load has to be balanced by pulley B as well. So now we need to pass the second string from the hook through the pulley B, okay, yes, and the other end of the string is now attached to the hook of the pulley C. Alright, now this T1 is balanced by this pulley B through the help of these two segments of the string, and the tensional forces acting on them are in the upward direction, and let it be T2. Right, now we need to have a support for pulley C. So now we'll pass another string through pulley C. Understand? Now one end is attached to this hook. Now other end of the string will pass through the pulley D, and through the pulley D we'll have one free end, and at this free end we'll apply the effort, and the effort is applied in the upward direction. So when I apply the effort, yes, so the tensional forces will be acting on the string. Yes, now this T2 is balanced by this pulley C, which in turn is balanced by this two segment of the string, and let the tensional forces acting on them be T3 and T3. And now since this first segment, second segment and third segment are of the same string, so the tensional forces acting on them will be equal. So tensional force acting here at this segment of the string will also be T3. Alright, so I hope you have understood how we have arranged or combined several pulleys, where one pulley here, in this case pulley D, is fixed, okay, pulley D is fixed, whereas pulley A, pulley B and pulley C are movable, whereas pulley D is fixed. So one pulley is fixed and other pulleys are movable. Alright, so now for this, let us find the mechanical advantage. Now you know, to find mechanical advantage you must need load and effort. Right, so how much is the effort here? So you see that this is the effort here, which is acting in the downward direction, and this effort is balanced by this segment of the string, and the tensional force acting on that string is T3. So we can assume, or we can write that the effort acting here is equivalent to the tensional force T3, which is acting on the free segment of the string, which is passing through the two pulleys, that is C and D. All right. Yes, so now we got effort equals to, so here we can write effort equals to T3, but we do not have load here, right? So now we must find load, isn't it? So load, if I come down here, this load L is balanced by pulley A, okay, pulley A is in turn balanced by pulley B is in turn balanced by pulley C, and pulley C is in turn balanced by pulley D. Right, so first let us begin from the lowermost, okay, that is pulley A. Now load which is attached to pulley A is balanced by two tensional forces acting on the two segment of the string here, that is T1 and T1. So I can write here, okay, I can write here load equals to T1 plus T1, because it is balanced by the two tensional forces acting on the two segments of the string passing through pulley A. Alright, so I'll get 2T1, or here I can make T1 as the subject. I'll get T1 equals to L by 2. So load I got as, the tensional force T1 equals to L by 2. Now you know, now this segment of the string is balanced by pulley B. So here I can write T1, okay, is balanced by T2 T2 plus T2, or I can write T1 equals to 2T2. All right, or I can make T2 as this subject. I'll get T1 by 2. But from this equation I know the value of T1. T1 is L by 2, so when I replace that I'll get L by 2 equals to 2, which in turn I'll get L by 2 square, isn't it? L by 2 square. And what is that? That is T2. All right, now if I go and see this T2, this T2 is balanced by pulley C, and pulley C is in effect of the tensional force, that is T3 and T3 here. So let me draw a margin here so that our calculation does not mix up. So now let's go for pulley. See, this is for pulley A, this is for pulley B. Now we are going to for the pulley C. So at pulley C, T2 is balanced by T3 plus T3, which in turn gives me twice of 2, 3, that is T2, isn't it? So from here I get T3 equals to T2 by 2. Yes, but I know from this equation that T2 is nothing but L by 2 square. So I'll get L by 2 square by 2, which means L divided by 2 to the power 3. So from here, when I make L as the subject, okay, L as the subject, I'll get L equals to 2 to the power 3 into 3T3. So here I get the value of L. L is how much? 2 to the power 3 by T3. So this T3 and this T3 gets cancelled. So I will get MA equals to 2 to the power 3. So I get that the mechanical advantage is twice to the power 3. Understand? So here what is actually 3, or this equation we can write in a general form, that is MA equals to 2 to the power n here. So now what is n at general condition, okay, or idle condition? N is the number of pulleys which are movable. So here you see that A, B and C, 3 pulleys were movable. So that's why we got the value of n equals to 3 here, isn't it? So here you saw that this n is equals to 3 here. So here we can say that whenever we are combining the pulleys, several pulleys together, where one of the pulley is fixed and the other pulleys are movable, so the number of pulleys which are movable, okay, gives us a idea about the mechanical advantage. So here 3 pulleys were movable, so we got mechanical advantage equals to 2 to the power 3. In place of n we have 3. Understand? So if we had 4 pulleys, okay, for this we would got MA is equals to 2 to the power 4. Understand? But this is applicable only when there is an idle condition, means the pulleys are frictionless and weightless. All right, but that is not possible. All right, okay, now we got mechanical advantage. So now we need to find the velocity ratio. Okay, now let's learn about velocity ratio, that is VR. Now you know VR is given by distance moved by the effort divided by distance moved by load. Yes, so now you know that in a single a combination of pulleys where one pulley is fixed, okay, so here you know this pulley is, okay, fixed. You have one pulley here, okay, you have another pulley and you have another pulley here, okay, A, pulley B and pulley C are movable. We have a string passing through it, isn't it, attached to the hook of the pulley B, another string passing through pulley A attached to the hook of the pulley C, another string passing through pulley C and passing through the pulley D, and this is our effort. All right, so here you know this is my load L. Understand? Now if the distance moved by load, okay, is x, so if the distance moved by this load is x, then what will happen? Pulley B will be, okay, pulley B will be moved by a distance of 2d. Why? Because there are 2 segments of the string here. So this string is also going to cover x distance, this string is also going to cover x distance. So distance moved by pulley B, okay, distance moved by pulley B will be twice of x. एउटा x यतापट्टि अर्को x यतापट्टि, so twice of x. Are you getting my point? Yes. Now similarly, distance moved by pulley C will also be twice, isn't it? Load भन्दाखेरि चाहिँ twice move हुन्छ. Understand? Distance load ko, if it is traveling x distance, then this pulley will be traveling double of it because of the two segments of the string. Understand? So our pulley C will also cover twice of this distance because pulley B has covered 2x. So pulley C is going to cover twice of this distance, that is 2 into 2x. Are you getting my point? So that is 2 square x. Are you getting my point? Now pulley C, which is attached to this pulley D, okay, or you can say that the string passing through the pulley D, which is fixed, will also be twice of the distance traveled by pulley C, that is of this, isn't it? So the distance, okay, so the distance traveled by the string, okay, that is this part of the string, will also be twice of this. So that is distance moved by the effort. So here this distance moved by the effort will be twice of 2 to the power x into x. So that will give you 2 to the power 3x. When I replace this distance moved by the effort, that is 2 to the power 3x divided by distance moved by the load, here is how much? X. X and x gets cancelled, so I'll get VR equals to 2 to the power 3. So here we are again getting the velocity ratio, okay, of the combination of pulleys where one of the pulleys fixed and the other pulleys are movable is given by the general equation, that is 2 to the power n. And what is n? N is the number of pulleys which are movable, and you know velocity ratio of a machine remains constant, it does not change, isn't it? Okay, so now let's find the efficiency. You know, efficiency is the ratio of mechanical advantage to the velocity ratio. So here mechanical advantage we got 2 to the power 3, and velocity also 2 to the power 3. Velocity ratio and efficiency are equal, so they get cancelled, so efficiency is equals to 1. If you find this efficiency in percentage, you will get 100%. So the efficiency of this kind of system is 100%. But you know, this is not possible in actual practice, isn't it? This is possible only when you have an idle situation, that is there is a pulley, okay, which is weightless, and the strings used are here, they are inelastic, and there is no friction at all. Alright, so this was the study of our combination of pulleys. The first one, that is using one fixed pulley and the other movable pulleys. Alright, now let us learn about the combination of pulleys in block and tackle. Are you getting my point? So here you see a diagram here, an incomplete diagram. Okay, here you see that in the first, okay, if I name them as A here and this is B, in A you have two blocks, upper block and lower block. Here you have set B where there are upper block and lower block. So in combination of pulleys, okay, in the two blocks we'll have upper block and the lower block. In the first block A, you see that the number of pulleys here are 5. In set B, you see number of pulleys is 4. Means this is odd, and here we have even number of pulleys. So remember, whenever you have odd number of pulleys, you will have one more. Here you see there are 3 pulleys in the upper block and 2 pulleys in the lower block. So upper block will always have one more pulley, okay, as compared to the lower block. Is that understood? Whereas if you in the even condition, number of pulleys in both the upper block and the lower block will be same, that is equal. Is it understood? Am I clear here? Okay, so now this block and tackle will be, okay, supported by a rigid support on the top, Okay, so here I have a hook which is supporting them. Here also I have a hook which is supporting them, here and here. All right, now how are we going to pass the string to them? Okay, string, in the sense we can call it as a tackle also. So that is why it is in whole, it is called as block and tackle system. So whenever you are passing, okay, the string, you always start from the topmost pulley. So here I have the free end. Okay, so free end is the place where you apply the effort. Now from the first pulley on the top, you have to go to the lowermost pulley, pass the string from here, then again go to the second topmost, pass the string from this pulley and go to the topmost pulley of the second or the lower block, and then you pass through the last pulley from the upper block, and the remaining, okay, string you pass and attach to the axle of this lower block. All right, so this is how you will make the string pass through all the pulleys. Now you know, at each and every segment the tensional forces will be acting in the upward direction. Now since each segment is the part of the same string, so the tensional forces acting on each of them will be T. All right, and this effort is also balanced by the tensional force acting here at this string in the upward direction by T. Is it okay? Is it understood? Yes. Now let's go to the number of pulleys when we have even. So again, as okay, as in the first case, here also we'll pass the string from the topmost pulley of the upper block. Understand? So here we'll apply the effort. Clear? Now from here the string goes to the lowermost pulley of the lower block, from here to here, and from this pulley to this pulley, and from here to this hook. Now see, one end of the string is what? Free. That is the point where you apply the effort, isn't it? Now tensional forces here will also be in the upward direction. Now this, you know, each and every segment of this string, each and every segment of the string is of the same string, isn't it? So the tensional forces will be T for each segment, and this effort will also be balanced by the tensional force acting in the upward direction, and that is how much? T. All right. Yes. Now what is the difference that you must see here? Okay, is, see here, okay, here free end is the place where you apply the effort. Okay, free end of the string is the point where you apply the effort, here and here. Now the other end, in this case, in case A, okay, in the case A, you see that here is the point where the string is attached, that is to the lower axle of the lower block. But in this case you see that here is the point where your string is ending, that is string is ending and at the, or attached to the hook of the upper block. So that is the main difference that you must remember whenever you are passing the string at the two blocks. Is it okay? Is it understood? It's clear here? Okay, if anyone is confused here, you can ask me. All right. Okay, now let us find the mechanical advantage. Now you know mechanical advantage equals to load by effort, right? Yes, load by effort. Now in this, let us learn the mechanical advantage for set A and set B separately. Is that okay? Now MA for set A, load. Now this is the place, okay, and let me use the red color. This is the place where you apply the load. Now this load is balanced by this segment of the string, this segment of the string, this third, and here fourth and fifth. So how many segments of the string is balancing the load? L here 5. So I can write 5T. Understand? Divided by effort. Now this effort is balanced only by one tensional forces here, so that is T. All right. Yes, so T and T gets cancelled and I get the mechanical advantage of the block and tackle of set A equals to 5. Now similarly, mechanical advantage for the pulleys for set B. Now here is the place where I apply the load or place the load. Load acts in the downward direction. It's balanced by the 4 segment of the string here. Yes, so how many segments? 4 segments. So I'll have 4T, whereas the effort acting here is balanced by only this tensional force T. So T and T gets cancelled, isn't it? So I get mechanical advantage equals to 4. Understand? Yes, clear? So you can get a clear idea here that the mechanical advantage here is 5 because there are 1, 2, 3, 4, 5 pulleys. Mechanical advantage here is 4 because you have 4 number of pulleys. In that way also you can remember. Understand? Now velocity ratio. Now velocity ratio is the ratio of the distance moved by the effort to the distance moved by the load. dE by dL. Now for this also, you know that the distance, if the distance moved by load is D, then the distance moved by the effort will be equal to the distance moved by each and every segment of the string. So here in case A, number of segments which is attached to the load is how much? How many? 5 segments. Yes, so the distance moved by the effort will also be how much? 5D. So D gets cancelled, so we'll get velocity ratio as 5. So similarly here in the shade B also you get distance moved by the effort to the distance moved by the load equals to 4D by D. D and D gets cancelled. You will get 4 as the velocity ratio. So you get the velocity ratio is actually equal to the number of pulleys, isn't it? So now let's find the mechanical efficiency. Now efficiency equals to, you know the formula, MA by VR. In the first set you got VR and MA equals to 5 and 5 each, so you will get 1, or you can write 100% as the efficiency of this block and tackle system. For the second also, you know MA by VR equals to 4 by 4, that is 1, or you can write as 100%. Now since you know that there is no machine which has 100 or which is 100% efficient, so this block and tackle system will also have efficiency how much? Less than 100%, right? Yes. So in turn you can see that mechanical advantage cannot be equal to what? How much? The number of pulleys here, because mechanical advantage is always less than velocity ratio, and you know velocity ratio is the quantity which always remains constant for a given machine or a given, in this case it's pulley. So we can see that in block and tackle system, velocity ratio equals to number of pulleys in this block and tackle system. So this is a very, very important thing that you have to remember. All right, but for a given block and tackle system, if the velocity ratio is 5, then its mechanical advantage will be always less than 5, because you cannot have a machine whose mechanical advantage will be equal to the velocity ratio. Is that understood? I hope you have understood this. Yes, so these are the ways in which you can combine the pulleys, or you can use several pulleys together by combining them in these two ways. Number one that we learned today is using one fixed pulley and other movable pulleys, and the other one is using several pulleys in two blocks, upper block and lower block, and this sometimes this is also called as block and tackle system. All right, so this is what we have to do today. If you have any doubts, any queries, you can always ask me in the class group. I'll try to solve it. All right, so that's all for today. Thank you.